Welcome to the Corrosion channel. My name is احتشام زاده. I am a researcher in the field of corrosion and protection of materials. Chapter 9, Section 12. Risk-based inspection. Relationship between RBI and other risk-based and safety initiatives. The main reference elements of a risk-based inspection program, API RP 580. 7 aspects of the relationship between RBI and other risk-based and safety initiatives includes 1. RBI as an integrated management tool, the PHA and RBI relationship. 3. The PSM program and RBI relationship. 4. The equipment reliability program and RBI relationship. 5. Integrity operating windows and RBI relationship. 6. The damage mechanism review and RBI relationship. 7. The fitness for service and RBI relationship. 1. RBI as an integrated management tool. RBI is a risk assessment and management tool that addresses an area of risk management not completely addressed in other organizational risk management efforts such as process hazards analysis, IOWs, or reliability-centered maintenance. Integration of these risk management efforts, including RBI, enhances a successful risk management program. RBI produces equipment inspection plans that identify the actions that should be taken to provide reliable and safe operation. An RBI program can provide input into an organization's annual planning and budgeting to define the staffing and funds required to maintain equipment operation at acceptable levels of performance and risk. RBI should be integrated within an overall asset integrity management system to be highly effective. This includes, but is not limited to, the connectivity to IOWs and the management of change process. In general, RBI methodology is also intended to complement other risk-based and safety initiatives. The output from these initiatives can provide input to the RBI effort. RBI outputs may be used to improve the risk-based and process safety initiatives already implemented by the organization. Examples of other initiatives are as follows. A. PHA HAZOPs. PHA stands for Process Hazards Analysis. HAZOP stands for Hazard and Operability Assessment. Acronyms and abbreviations are available on video number 43 or Chapter 9, Section 5. B. OSHA PSM programs. OSHA stands for Occupational Safety and Health Administration. PSM stands for Process Safety Management. C. EPA Risk Management Programs. EPA stands for Environmental Protection Agency. D. American Chemistry Council Responsible Care. E. American Society of Mechanical Engineers Risk Assessment Publications. F. Center for Chemical Process Safety Risk Assessment Techniques. G. RCM and FMEA. H. Safeguarding Analysis. I. Safety Integrity Level. J. Layers of Protection Analysis. K. Corrosion Control Document Programs. And L. Fitness for Service Programs. 2. RBI as an integrated management tool. A PHA uses a systemized approach to identify and analyze hazards in a process unit. The RBI assessment can include a review of the output from any PHA that has been conducted on the unit being evaluated. Hazards associated with potential equipment failure due to in-service degradation identified in the PHA can be specifically addressed in the RBI assessment. Potential hazards identified in a PHA will often affect the probability of failure side of the risk equation. The hazard may result from a series of events that could cause a process upset, or it could be the result of process design or instrumentation deficiencies. In either case, the hazard may increase the probability of failure, in which case the RBI assessment could reflect the same. Some identified hazards affect the consequence of failure side of the risk equation. For example, the functional failure of an isolation valve could increase the inventory of material available for release in the event of a leak. The consequence of failure calculation in the RBI procedure could be modified to reflect this added hazard. Likewise, the results of an RBI assessment can significantly enhance the overall value of a PHA and help to avoid duplicate effort by two separate teams looking at the risk of failure. 3. The PSM program and RBI relationship. PSM stands for Process Safety Management. An effective PSM system can significantly reduce risk levels in a process plant. RBI may include methodologies that allow the risk assessment to evaluate the effectiveness of the PSM program, particularly in maintaining the mechanical integrity program. Several parts of an effective PSM program can provide input for an RBI assessment. For example, intensive data on the equipment and the process are required in the RBI assessment, and output from PHA and incident investigation reports increases the validity of the RBI assessment. In turn, the RBI program can improve the mechanical integrity aspect of the PSM program. An effective PSM program includes a well-structured and effective pressure equipment inspection program. The RBI system will improve the focus of the inspection plan, resulting in a strengthened PSM program. Operating with a comprehensive inspection program should reduce the risks of releases from a facility and should provide benefits in complying with safety-related initiatives. 4. The Equipment Reliability Program and RBI Relationship. Equipment reliability programs can provide input to the probability of failure portion of an RBI program. Specifically, reliability records can be used to develop equipment failure probabilities and leak frequencies. Equipment reliability is especially important if leaks can be caused by secondary failures, such as loss of utilities. Reliability efforts such as RCM, FMEA can be linked with RBI, resulting in an integrated program to reduce downtime in an operating unit. RCM stands for Reliability Centered Maintenance, and FMEA stands for Failure Modes and Effects Analysis. At facilities with an effective RBI program, the RCM program can typically focus on the reliability aspects of equipment other than pressure equipment. Other programs in a similar manner could also focus on the reliability aspects within the pressure boundary that do not pertain to loss of containment, for example, tray damage and valve reliability. 5. Integrity operating windows and RBI relationship. RBI assessments and the information therein, when evaluated and produced according to the guidance within this document, may be combined with a comprehensive set of IOWs. Once an active IOW program has been established, the selected operating parameters will have operating limits. Deviations from these limits can be analyzed and brought to the attention of the appropriate personnel for corrective action. After review, these deviations may require a revision to an RBI assessment. Please refer to API 584 for more information regarding IOWs. For example, an effective set of IOWs can avoid operating in areas where damage mechanisms are accelerated or unanticipated DMs or damage mechanisms might occur. Damage mechanisms are covered in the videos titled Chapter 3 on this channel. For example, effective MOC management of change can also prevent making process or physical changes that might also cause damage mechanisms to be accelerated or anticipated damage mechanisms to occur. Management of change is the title of video number E32 or Chapter 10, Section 5. 6. The damage mechanism review and RBI relationship. A DMR can be conducted focused on the RBI assessment, or a DMR may be performed and documented in a CCD corrosion control document per API 970 and then used in performing an RBI assessment. Some users have found that creating CCDs helps perform the RBI assessment because the DMR is documented to a much greater extent than is typical for an RBI assessment. A damage mechanism review for a corrosion control document and an risk-based inspection assessment are very similar, and the corrosion control document forms the basis for the RBI assessment. 7. The fitness for service and RBI relationship. The relationship between FFS and RBI is synergetic. The RBI assessment identifies equipment that potentially has a high probability of failure, and fitness for service assessment for this same equipment can determine the actual damage tolerance and remaining life and determine if any defects found during the inspection are acceptable. Updating the risk assessment with the results of an FFS analysis can improve the accuracy of the probability of failure by reducing uncertainty and validate the risk level. Challenge number 51. Thank you for your time and attention. If you'd like to challenge yourself, please answer these questions in the comments below. 1. What's the definition of integrity operating windows? 2. Describe how an effective process safety management system can significantly reduce risk levels in a process plant. 3. Why does creating corrosion control documents help perform the RBI assessment?